Good morning. Good morning. Hope all is well. Let's
Good
see.
morning.
Hey, sir. How's it going?
All right.
All right. Cool. All right. Looks like everybody's in who is in. So, before I go and look at anything new today, anybody have any general questions or concerns or any problems they want me to run through? Everybody good? Everybody straight? All right. Where are we? Okay, we did that last time. Okay. This is 13.5. Okay. So this is 13.5 for you guys. And it just says factoring binomials, but the title still holds true. You know, it's factoring special products and difference of squares. So, but the binomial part is right here. They're binomials, but we're going to expand them out according to the formula that's given to us. All right. So the first one that they give us is the difference of squares. I should have made that a different color, but anyway, difference of squares is the first relationship that they give us. Says now difference means subtraction. So this only applies this relationship, this formula, excuse me, only applies when you have the difference, the subtraction of perfect squares. In other words, your first term is a perfect square and your second term is a perfect square. And once again, you are subtracting them, the difference of squares. So it's in the title. Um, if you have the subtraction of two perfect squares, you can break it up this way, wherein whatever the square root of x squared is x, the square root of y squared is y. So then you can just do x plus y, x minus y. So here we have a simple example of that type of scenario. We have a squared minus 25. A squared is a being squared. 25 is 5 being squared. So that's what I was emphasizing right here. So now if you don't see that relationship, then you can't apply this formula. It has to be the first term being squared minus the second term being squared. And then whatever those perfect roots are, a plus 5, a minus 5. All right, so before we do another one, is everybody okay with the concept? All right. So the next one down here, same type of thought process. Are they perfect squares? If they're not perfect squares, I cannot use this formula right here. So you have to establish what are the perfect square roots. So looking at 49s squared, that's 7s that's being squared. 4t to the fourth, well, that's 2t squared being squared. All right, make sure we're okay with that. So you're looking at taking the square root of each one of your terms, seeing if they can be taken the square root of. And if both of them are, and once again, subtraction, we're doing subtraction, then that means I can break it up into whatever their roots are, plus or minus in between. All right. Questions on that before we go to the next one? All right, next one. 18w squared z minus 2z. So notice, remember, we mentioned it before. First thing we want to do is to factor out the GCF if possible. It's always the first move to make if it's there. The first two that we just did, there was no GCF to pull out. So it was nothing to discuss. But here we could factor out 2z from each term. And that leaves us with 9w squared minus 1 inside of the parentheses. Now you want to look at each one of those terms that's in the parentheses because we see the subtraction. So we're good with the difference part. Then you want to ask yourself, is 9w squared a perfect square? Is 1 a perfect square? And that's what I emphasize right here. 9w squared is 3w being squared. And then 1 is 1 being squared. And since they are perfect squares, and we have the difference of those perfect squares, you can break it up like this. All right. Questions before we go to another example? All right. Next, we're looking at the sum of squares. Now, sum is addition. Before we had the difference of squares, now we're looking at the sum of squares. Difference is subtraction, sum is addition. Notice the sum of squares cannot be factored. It's prime. So there's nothing to do there, no work there. There's no formula for it. It cannot be done. At least not with real numbers. Not with real numbers. I'll say it like that. So we write prime. So if I were to change that minus sign to a plus sign with that a squared minus 25, my answer would be prime because I cannot factor that with real numbers. All right, any questions? So here, just doing a comparison, a clean comparison between the two. If I had p squared minus 9, that's p plus 3p minus 3. But if I had p squared plus 9, that would be prime. All right, so let's just leave it up. Here we have w to the fourth minus 81. Here's my breakdown. W to the fourth is w squared squared. 81 is 9 squared. So that means I can break it up. W squared plus 9, W squared minus 9. Any problems with that breakdown? Is everybody okay with that part? All right. So W squared plus 9 cannot be factored. Just talking about being prime. Now W squared minus 9, though, is another perfect square. So you remember your directions will be factored completely. So if you factor it once, it is possible to continue factoring. So you do want to make sure you factored it completely. So I can break up that W squared minus 9 into W plus 3, W minus 3. And so this would be my complete factorization. W squared plus 9, W plus 3, W minus 3. All right. Questions? Any questions? All right. Next two formulas, difference of cubes and the sum of cubes. So the formulas are very similar, except your signs are going to change according to what you have initially. So here we have the difference or the subtraction of two perfect cubes. So once again, we're looking at cubes now, not perfect squares. So if we have difference of cubes, that should factor out to give us x minus y, x squared plus xy plus y squared. And then looking at the sum of cubes, it's the same positioning of our letters, except our signs are going to be different. If I start off with x plus y, x cubed plus y cubed, that's going to be x plus y, x squared minus y, xy plus y squared. So one way to remember it is SOP, same, opposite, plus. So in other words, this is going to be the same as what you had initially. This is going to be opposite, and then this back sign will always be plus. You know, comparing it to your first sign. So comparing it to our first sign, this is the same, this is opposite, and this is plus. All right. So let's try to use this. Original problem is w cubed plus 64. Now, before you go any further, you have to first establish, are these perfect cubes? Are they perfect squares? What are you dealing with? So w cubed, you know, that being w cubed lets you know off the top that you know you're not dealing with perfect squares. It can't be a perfect square because w cubed is going to eliminate the option of square. So now you're trying to examine, do you have perfect cubes? W cubed is W being cubed, so we know that's a perfect cube. But 64 is 4 cubed. So you know you have perfect cubes now. And we have the sum of perfect cubes because of our addition sign. So that means we're going to use this formula right here. And so that means W is going to go in the place of X. 4 is going to go in the place of Y. That's why I tried to emphasize by using these arrows. And that's what we did right here. So where I saw X in the formula, I put W. Where I saw Y in the formula, I put 4. So that's Y plus 4, Y squared minus W, 4 plus 4 squared. And then you simplify the expression. W plus 4, W squared minus 4W plus 16. Any questions before we do another one?
Yes, I have one question.
Mm-hmm.
Okay, so the first parentheses is just telling you how you got the 64, like the W plus 4.
So let me ask, you said, when you said first parentheses, you talking about this one?
Yes.
Now, you said, is it telling you how you got 60? Well, I see what you're saying. Whatever your perfect cubes are, that's what it should be right there. Your
Yeah,
perfect
that what
cube.
that's saying.
Mhm. Well, it's not really, that's what it's saying, but that's what will be there. Because
Okay.
what's going to happen is if you were to multiply this back out, then multiply this back out, it will give you this right here. Because of
Okay.
that minus sign and those some stuff is going to get distributed, it's going to cancel out, and you're just going to be left with these two terms. Yeah.
Okay.
Yeah, it's just a part of the factorization. But if you want to look at it that way and say, okay, whatever my perfect cubes are, in other words, this statement right here is going to be the first part of my factorization. And if that's what helps you remember it, then that's fine. Yeah.
Okay, thank you.
Mm-hmm. All right, let's look at another one. So here's the original problem right here. 27p cubed minus 1000 q cubed. So once again, we have to establish, are these perfect cubes? The numbers and letters and all. So don't forget your letters when it comes to this stuff. So 27p cubed is 3p being cubed. 1000 q cubed is 10q being cubed. So once you've established that you have perfect cubes and what they are, once again, the first one, which is 3p for us, that will go in for x in the formula. 10q will go in for y in the formula. And so once again, make sure you pay attention to your signs because we're dealing with subtraction, the difference of cubes. So that'll be 3p minus 10q, and then 3p squared plus 3p times 10q plus 10q squared. All right, so now simplifying, we want to make sure we're careful. A lot of times people will mess this up right here, these two pieces. When you have that 3p being squared, you have to square the 3 and the p. Same thing with a 10q, square the 10 and the q. So when you simplify that, the 3p minus 10q stays the same. That's what you would have done with that. But then 3p squared is 9p squared. 3p times 10q, 30pq. And then 10q squared is 100q squared. So it's really just about establishing if you have perfect squares or perfect cubes, and then using the formula accordingly. All right, looking at another one. 125a cubed plus 1. Once again, are they perfect cubes? If they are not perfect cubes, then you cannot use, these relationships or this formula. So 125a cubed is 5a being cubed, and 1 is a perfect square, is a perfect cube, is a perfect whatever, because 1 times 1, no matter how many times, is going to give you 1. So 1 is our perfect cube. So once you've established that, now we have the sum, the addition of two perfect cubes. 5a go in for x, 1 goes in for y. So that's 5a plus 1, 5a squared minus 5a times 1 plus 1 squared. All right. Go ahead and reduce, simplify. 5a plus 1, 25a squared minus 5a plus 1. Any questions? Can I scroll up? Okay. So here we have 4x cubed plus 4x squared minus 25x minus 25. So no matter what section you're in, don't forget your techniques. You know, whenever you have four terms, we're supposed to be leaning on factoring by grouping. So that's what we will do here. So that initial move has nothing to do with difference of squares, difference of cubes, sum of cubes, or anything like that. It's what we've talked about previously. We see four terms, so it's like, okay, now I need to use factoring by grouping. So that's what I did here. Group together the first two, group together the second two. Also emphasizing the idea that since I had this minus sign right here, it needs to stay attached to the 25x. And so that's why it's in the parentheses. All right. So whenever factoring by grouping, you want to factor out your GCF of each parentheses. So I was able to pull 4x squared out of this one, and that left me with x plus 1. I was able to pull out negative 25 from this one. That leaves me also with x plus 1. So don't forget, when it comes to factoring by grouping, what's left in the parentheses has to be the same. If it's not the same, I can't move any further. So you do want to make sure you, when you're doing your factorization, when you're pulling out your GCF, that what's left in parentheses is the same. If not, and like I said, you either need to check your factorization or go back and see if you can rearrange terms or something of that nature. Because if they are the same, then I can pull them to the front because that's what they have in common. And then I'm left with what was sitting in front of those parentheses, which is 4x squared minus 25. All right. And then don't forget, remember I mentioned before, the directions will be to factor completely. So you do want to examine what you just factored and see if there's anything you can do to factor or break it down even further. So you see right here, 4x squared minus 25 is a difference of squares. So that 4x squared is 2x being squared. 25 is 5 being squared. Since that is the case, we have the subtractions of two perfect squares. I can break it up into 2x plus 5, 2x minus 5. And of course, don't forget the x plus 1 that we had from our initial factorization. All right, any questions? We already did perfect square trinomials last class. All right, any questions on any of those before we go anywhere else? So it will be imperative that you guys practice factoring. A lot of people don't, sometimes people take for granted that you don't know if you can or can't do something until you try it. You know what I mean? So, it will be imperative that you guys try this factoring out, see if you get stuck on anything, see if you have any questions or issues so that we can address them, bring them to class so we can, talk about them. Or if by some chance, you don't want to, bring your example to class, and feel free to ask questions through emails or set it up so that we can have an outside session to discuss these, because the next chapter is going to depend on your ability to factor. So you do want to get on this factoring very soon. All right, questions before we do one more thing today? All right, let's see what's here. Yeah. All right, last section out of chapter 13 is solving quadratic equations. Before we close out today, don't let me forget to talk about testing. Don't let me forget. So I just want to throw that out there. So solving quadratic equations. Up to this point, we've solved linear equations. Example of that is x plus 1, equal to 0, wherein we would get one solution. And we would get one solution, our highest degree. Oh, yeah, don't worry about it. Degree of polynomial, something other than 1. Yeah, don't worry about that. Yes, I was just reading this to see if this was pertaining to you guys. But don't worry about that. That I have scratched out. That's for another class. They never asked yet. So, linear equation, x plus 1 is equal to 0. You're only going to get one solution. But here, quadratic equation, you're going to get two solutions. Your highest degree of your exponent is 2. You're going to get two solutions. All right. Even if it's a repeated solution, still, you would have gotten 2. So when we go solving here, we should be looking to get 2 solutions. All right. So we have the zero factor property or the zero product rule, depending on which one your book called it. So the key here, if you look at zero factor property, is at first you have to have one side set equal to 0. And then the other part of that is that we're using factoring in order to solve. So it says if A times B is equal to 0, then A is equal to 0, B is equal to 0, or both. All right, so the first thing we want to do is have one side set equal to 0. If we have one side set equal to 0, then we can factor. Then after that, we take each factor, set it equal to 0, and solve that. So this is what we mean with that. Let's say we had our trinomial and we broke it down to x plus 2 times x plus 3. Once I have my two factors, x plus 2, x plus 3, I can set each one equal to 0 and get my two solutions by solving those. So x plus 2 equal to 0, x plus 3 equal to 0, subtract 2 from both sides, x is equal to negative 2, subtract 3 from both sides, x is equal to negative 3, and those would be my two solutions. And so that's what we're looking to do. If we have a trinomial, take it, break it down to your binomials, and then set each part equal to 0 after you factor completely. After you set them equal to 0, then you can solve them. Mm-hmm. So here, just gave you steps written out. Pretty much what I've already said. Step 1, set one side equal to 0. Step 2, factor completely. Step 3, set each of the factors equal to 0 and then solve each factor. And so that's what we're talking about. That's what we did up here. Just that we didn't have the solving, the factoring part, because we already broke it down to the factors of x plus 2, x plus 3. But we're going to factor, set one side equal to 0. Make sure one side is set equal to 0. Then we're going to factor completely. Then set each one of those pieces equal to 0 and then solve each one. Mm-hmm. So let's look at this first one. We have 5x squared plus 8x equal to 0. So you want to factor that out as much as possible, if possible. And what I did here was I factored out the GCF. I pulled the x out of each term, so that's why my x is sitting on the outside. And I have 5x plus 8 inside of the parentheses. Now I set each part equal to 0, x equal to 0. There's nothing to solve there. There's just going to be a solution. It's okay for a solution to be 0. Then I set 5x plus 8 equal to 0. Subtract 8 from both sides, then divide by 5. My other solution is x equal to negative 8 over 5. Any problems? All right, next one, we have p squared plus 3p minus 10 equal to 0. That goes back to us factoring the other day. P plus 5, p minus 2. All right. So, different signs because we had a subtraction in the back, and then the greater number should take on that positive sign because that's what's in the front. Then we look at our factors of 10 that will subtract from each other to give us 3 in the middle, which is 5 and 2. So that's how I got p plus 5, p minus 2. Set both of those equal to 0 and then solve. So p plus 5 equal to 0 gives you p equal to negative 5. P minus 2 equal to 0 gives you p equal to 2. Any questions? All right. Next one, we have 8k squared minus 47k equal to 6. So here we see that the first thing we have to notice is that we don't have one side equal to 0. We have it 6 on one side. So we want to set one side equal to 0 by subtracting 6 from both sides. And that puts us, whoa, my eraser's still on. That'll put us right here at 8k squared minus 47k minus 6 equal to 0. So from there, we want to factor this out, exploring what I have as options for 6 and 8. What two numbers will multiply to give us 6, what two numbers will multiply to give us 8. Excuse me. So we know we have to have different signs. And we also want to get 47 in the middle. So the easiest way or the closest way for us to get 47 is to do 8 by 6, 8 times 6, and then that puts our ones in the middle. So it's just a way of looking at it. But if you just play with the numbers and, like I said, some stuff, the more you do it, the less it becomes trial and error. And so for some of us, it's just about getting in there and start, using these different combinations, seeing what doesn't work and what does work. And that's how you will get your practice in and get more efficient at doing your factorizations. But the factorization for this will be 8k plus 1 times k minus 6. And then once you do that, 8k plus 1 equal to 0, k minus 6 equal to 0. Go ahead and solve those, subtract 1 from both sides, divide by 8. K is equal to negative 1 over 8. And then add 6 to both sides for the other one. K is equal to 6. Questions? Any questions? All right. Scroll up. All right, the next one. 5n cubed minus 65n squared minus 150n. So once again, we don't have one side equal to 0 yet, so we want to do that. And we can subtract, not subtract, but add 150n to both sides. And that gives us 5n cubed minus 65n squared plus 150n equal to 0. So now looking at our highest exponent, that is 3. So that means we should get 3 solutions this time. And so what we can do first, remember, we should always be looking for it. If it's there, factor out the GCF. And what I did was I factored out n from each term. Factored out n from each term. And that leaves us with n squared minus 13n plus 30 on the inside of the parentheses. Then from there, factor that trinomial to n minus 3, n minus 10. Once you factor completely, set each piece equal to 0 and solve. So 5n equal to 0. Divide by 5, n is equal to 0 for a solution. Next one, add 3 to both sides, n is equal to 3. Then the last one, add 10 to both sides, n is equal to 10. All right, any questions, any questions? All right, let's look at another one. I think this is the last one though. Yeah. All right, here, w cubed plus 6w squared minus 9w minus 54 equal to 0. Once again, if we have 4 more terms, we're going to factor by grouping. So here is my grouping. W cubed plus 6w squared plus we have that negative 9w minus 54. All right, factor the GCF out of each parentheses, each grouping. So in the first one, I can factor out w squared, leaving me with w plus 6 in the parentheses. Second one, pull out or factor out negative 5, leaving me with w plus 6 in the parentheses. Now, each expression has w plus 6 in common. So I extract or factor out the w plus 6, bring that out to the front. That leaves me with w squared minus 9 in the parentheses. And once again, we want to factor completely, and we recognize that that is a difference of squares. W squared minus 9 is a difference of squares, so we keep going. W squared minus 9 will factor out to give you w plus 3, w minus 3. If you have those perfect squares being subtracted, find out what those square roots are, and plus or minus those. So now we have our expression factored completely. Now we set all three pieces equal to 0. And we'll have our three solutions when we solve. All right. Any questions? Any questions? All right. So that is it for chapter 13. Yep, that's the one we in. So that is it for chapter 13. So as far as new content, new material. So like I said, make sure you guys get in there and get to this stuff. I know a few of us are behind, so you want to make sure you do your best to get caught up and then start knocking out each test. So next class, what I'll do is, you know, have it open for you guys to take a test. It doesn't matter which test. So you just come in and let me know which test you're trying to take. Come to the class, show your ID. So I know if you came to individual sessions, then you show your ID before. There's only been like 2 people that have done so. So everybody else, you got to make sure you come to the recording, come to the session and show your ID. You got to do it at least one time to validate, you know, you are who you are. And then once you do that, I'll give you the password, and then we can go from there. But we got to get these tests in, guys. And so I'll give you the opportunity to do so on next class. Now, if you're not ready to take a test, or if you're already taking a test and you're in between tests or something like that, you still can come and get help. And so what all I would ask is that, you know, if somebody don't want to hear my voice, they can just, you know, cut their volume down and work on the test. But, you know, when you come to take your test, you're supposed to leave your Zoom up and leave everything up. So don't forget that element of it as well. You come there, show your ID, I give you the password, you take the test, and you leave your Zoom application up while you're in my math lab taking your test so that your camera's still on you. But like I said, though, if somebody has questions on something and they wanted to, you know, run through some problems, we can still do that. It's just that for those who are taking the test, you guys just turn your volume down. So, you know, if me talking, you know, bothers you or something like that. So we can, you know, knock out 2 birds with 1 stone. All right. Anything else? Anybody else before we close today? All right. Everybody good? Everybody straight? All right. So once again, next class, come prepared for testing. You know, you got this weekend to study and try to put yourself in a position to be ready to take a test. And then, like I said, but if you're in between tests or just not ready, and you got some questions, then we can knock that out as well. All right. So if you guys are good, I'm good. Have a great weekend. Be safe. And I will see you on what? Tuesday? No, Monday. Your class is Monday. See you on Monday. You guys have a good one.
All right.
All right.
Have a nice one.
Thanks. You do the same.